This is a response video to the video that was posted, to the problem that was posted by one of my all-time favorite physics teacher, Dr. Lewin. You can check out the details of the question over here. Please click on the annotation. Please check out the details over there and then come back over here. All right. So we need to calculate what is the value of x. So here is x, and let's say here is the center of mass, LMG, that's what's given. What is the value of x so that I get the same time period as the time period over here, and that time period turns out to be 2 pi square root. I actually forgot what the time period turns out to be. Let's see what that turns out to be. 3L by 2G. 3L divided by 2G. Now the moment I saw the problem, I started recording this. So I have absolutely no idea what's going to turn up. So the first thing I'm going to do is I'm going to do brute force. I'm going to go mathematical, okay? And then I will try to reason this out logically without using numbers. So the first step is I'm going to build a differential equation. And by the way, this diagram is wrong. I am oscillating at about this point, right? So let me change that diagram. Okay, there we have it. So I'm oscillating at a point distance x below one of the edges. All right, so let's build a differential equation. The differential equation is going to be tau, that is the torque acting on this rod with respect to this point, this new point P, should be equal to should be equal to moment of inertia IP times theta double dot. Okay, I just have to build a differential equation. What is causing the torque? The torque is caused due to the gravitational force mg, and the torque due to that is going to be mg times this distance. I have to calculate what this distance is, and that distance is just the horizontal the horizontal component of this distance, okay? And that of this one, and that distance is just L by 2 minus x. So it's going to be mg times the horizontal component, L by 2 minus x. Its component over here, this is theta sine theta, but sine theta is almost equal to theta because theta is very small, and that should be equal to the moment of inertia of this rod with respect to this point, and that's going to be, well, I have to use parallel axis theorem. And so parallel axis theorem, I have to know the moment of inertia with respect to center of mass. I know that. That is ml squared divided by 12 plus m d square. Well, it has to be L by 2 minus x the whole squared. Alright, so this is going to be the moment of inertia times theta double dot. And theta double dot has a negative sign. So this is going to be a tiny negative sign, and the reason for that is because notice that the torque and the angle theta, you know what, actually it's not that. This one has a negative sign because the torque is in the opposite direction of theta. Torque is clockwise and theta is anti-clockwise. So anyways, I can now bring this in the standard form. Theta double dash has to be equal to, m cancels everywhere, has to be equal to, let's see, no, not has to be equal to, wait, theta double dot plus, okay, that's what I want. So let's cancel that. Theta double dot plus, what do I get? I get g times L by 2 minus x divided by L squared divided by 12 plus L by 2 minus x the whole squared times theta has to be equal to 0. Hopefully I've not made any errors over here. Please, God. Okay. And that tells us that this monstrous equation over here in the bracket, the brace bracket, has to be omega square of this oscillation. Okay. So let's first check whether it has the units of omega square, because if it doesn't, everything is screwed up. So g is meters per second square, and I have numerators of meters, I have denominator meter square, this cancels. Awesome. Okay, everything is fine. So g times L by 2 minus x divided by L squared divided by 12 plus L by 2 minus x the whole square should have the same thing as the omega square for this guy. And the omega square for this guy would be, I have to first calculate the frequency, which is going to be 1 by, so it will be 1 divided by 2 pi square root of 3g by 2L. And then the omega square is just going to be, get rid of this, so omega is just going to be, get rid of this, and you square this, so it's going to be 3g by 12, 3g by 12, 3g by 12, 3g by 12, 3g divided by 12. Can you see that I have a very poor memory power? Yes, sir, indeed. Okay. Now, moment of truth. Whether I'm going to get any sane value for x. Let's check that. So I'm going to bring... Okay, time to club everything together. So I will get L squared. Oh, wait. You know what? This cancels. Awesome. Right? Yes, that cancels. And so I now get, if I bring this on this side, I get 3Lx minus 2Lx. I get Lx equal to 3x squared. That gives me one solution, x equal to 0, because I'm going to cancel this. And you know what? I'm very happy I get x equal to 0, because even before I go forward, I'm very happy because x equal to 0 is a trivial solution. It makes a lot of sense because you know what? If this point was back over here, you would expect to get the same time period because it would be going back to the same problem. So that tells me that I'm on the right path. It doesn't mean that this is absolutely right. I might have done some mistakes, but I think this is right, okay? So now this tells me that x has to be equal to L divided by 3. Now the question is, does x equal to L divided by 3, does it lie between 0 and L by 2? And the answer is yes. L by 3 lies in between 0 and L by 2. So yes. We have gotten the solution. Ta-da! There we have it. So at that point, I should get the same time period as this one. So now let's try to. I think this was easy for me. This was absolutely easy. It was not much of physics. It was more of algebra that I hated. But I think the hard part comes now. I'm going to try and attempt to think this through logically without any numbers. So let's try this again without any numbers. I don't think I'll be able to get this answer without numbers, but let's see whether it makes sense as to why I'm getting an answer which gives me the same answer as oscillating over there. So here is my logic. I think this is okay. So logic. My logic is this. Look, as you start moving closer and closer towards the center of mass, there are two things that start changing. One is the torque. You see, since torque is just the force multiplied by the horizontal distance from the point of pivot, as the point of pivot comes closer and closer to the center of mass, the torque decreases. What does this do? If the torque decreases, then the angular acceleration would decrease, and that tends to increase the time period. Does that make sense? I mean, think about it. If the point P were to come right at the center of mass, you wouldn't expect the thing to oscillate at all. Time period would go to infinity. So as P approaches center of mass, torque approaches 0, and the time period approaches infinity. Okay, that's first thing. The second thing, and so that increases the time period. Okay, and the second thing is about, of course, the moment of inertia. Well, as P approaches this point, notice that according to the parallel axis theorem, the farther you are from the center of mass, the more moment of inertia you get. I mean, every time you have raised a cricket bat, you must have experienced that, right? And, you know, you score a half century, you raise your cricket bat, whatever. Okay. Anyways, you're farther away. But so if you come closer and closer to the center of mass, then the moment of inertia decreases. So this tells us that the moment of inertia also decreases. as P approaches the center of mass, the moment of inertia approaches the minimum value, and that is I of Cm, and that is ml square divided by 12. Ooh, this is interesting. Both of them start decreasing. That's very interesting. Okay, and so the question is, what is going to become to alpha? You know what? That's, I think, the main question over here. How does alpha change? Because both are decreasing. I don't think logic is going to cut it, right? I don't know. Which one decreases faster is my question. Which one decreases faster? Well, I feel torque decreases faster because torque goes from the maximum value to zoop 0. But the moment of inertia goes from maximum value to not 0. And so for that reason, I feel torque decreases much, but I don't know exactly what's going on. Let's see. So as I come closer and closer and closer, if the torque decreases much faster, I would expect the time period to increase. I would expect the time period to increase, right? Yeah. But then why does the time period become the same at a specific point? Oh, this is very interesting. Well, let's see. How does the torque decrease? The torque is proportional to L, and the moment of inertia is equal to ml square by 12 plus, what was that? It was plus this distance, so plus m into L by 2 minus x the whole square. I did not expand this ever. Let's just expand this and see what the function I get. 12 plus m L square by 4 minus m L x. Yeah. You know what? All I understand is, I think it has a factor of x squared. Okay? And so here is my guess as what's going on. Initially, if I were to go a little bit down, that is between 0 and L by 3, the answer which I got, I'm cheating now. I think over there what happens is that the moment of inertia decreases much quicker. I think that's the answer. The moment of inertia initially decreases much quicker, and therefore the time period, you see, the torque doesn't decrease as much. The moment of inertia decreases much quicker, and because of that you would expect the time period to actually you would expect the time period to actually decrease. Okay, so I don't know, this is my rough guess. You would expect the time period versus x. Okay, if the x is 0, then the time period is some value over here. Okay, and that is that value gotten by Dr. Lewin in the previous episode. Now, as x increases, I'm expecting, I think that the moment of inertia decreases much quicker. If the moment of inertia decreases much quicker, and the torque doesn't have that much of an effect, the decrease in the torque doesn't have the effect, then it becomes easier to accelerate that, because the moment of inertia, and therefore the time period becomes smaller. So I would expect this to shoot down. But then after some point, what I think will happen is the torque will start decreasing much quicker, and after that this starts going further up. All right, yeah, and then I think it asymptotically, so if I draw this as x equal to, I'm very excited, as x equal to L divided by 2, I think it asymptotically approaches infinity. Okay, and I think it's this point which we are getting as L by 3 when you do it mathematically. So there must be only one point. I think the only way to confirm that is to check whether dt by dx has a minima. But I don't want to do that. It's 1240 and I don't want to do that. Okay, so I think this is the solution. So mathematically I don't think it's very challenging. Hopefully I've not done any mistake, because if I have, then this would be very embarrassing. So I'm going to upload it as it is, and let's just find out what the solution is. So see you next time.